students, this is the continuation of exercise 3.6 of class 10 mathematics, and this is the last exercise of this chapter and the last three questions of this chapter. Question number 2. Formulate the following problems as a pair of equations and hence find their solution. Simply, three word problems are given. First of all, we have to form the required pair of linear equations and then solve it by any algebraic method. Question number 1. Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. Find her speed of rowing in still water and the speed of the current. In class 8, you might have seen this type of questions. Speed of stream and speed of rowing in still water. There are two unknowns in this question. Number 1, speed of rowing in still water. Number 2, speed of stream or speed of the flow of water. If the speed of, let the speed of rowing in still water is equal to x kilometer per hour. Let the speed of rowing in still water is equal to x kilometer per hour. And let the speed of stream, S-T-R-E-A-M, speed of stream or flow of water be y kilometer per hour. If the speed of rowing in still water is x and the rate of flow of water or the speed of stream is y, then when you go downstream, what will be the actual speed? While going downstream, your actual speed will be x plus y. I hope this point is known to you, because x is the speed of rowing in still water and y is the speed of flowing water. So this speed of flowing water will be advantage when we go downstream. So automatically or freely you will get this 5 km per hour speed extra to speed in still water. That way we are flowing easily downwards. But it is very difficult to flow upward. While going upward, you have to overcome this 5 km per hour. So speed downstream is equal to, therefore, speed downstream is equal to x plus y kilometer per hour. Now speed upstream is equal to x minus y kilometer per hour. This point is to be noted. If the speed in still water is x and the speed of stream is y, while going down, that is downstream speed will be x plus y and upstream speed will be x minus y, because you have to row against the speed of stream. So that y kilometer per hour will be acting in the opposite direction. So it will become x minus y. Now see the question. It is given, Ritu takes 2 hours for going 20 km downstream. So speed downstream 20 km. So we can write, according to first condition, speed downstream is there already. Distance downstream. Distance downstream is equal to 20 km. Time taken is equal to 2 hours. This is distance, this is time, and this is speed. What is the relation between the three? Distance is equal to speed into time. So we know that, or therefore distance 20 is equal to speed x plus y into 2. We have used the formula distance is equal to speed into time. This 2 and 20 can be get cancelled. So the first equation is x plus y is equal to 10. This is a much easier method than the method given in your NCERT book. If you look at NCERT book solution, it is very long, very lengthy. So I am giving you a very short and easy method. This speed downstream x plus y, distance downstream 20, time 2. Now the relation distance is equal to speed into time, or you can write that also in between. We know that distance is equal to speed into time. Therefore 20 is equal to, or that is 20 is equal to x plus y into 2. 2 got cancelled. X plus y is equal to 10. This is equation number 1. Now, let's see how can we make equation number 2. Speed of stream x minus y. Now, according to second condition, speed upstream x minus y, that is still water minus speed of stream, and it is given the second condition, and upstream 4 kilometer in 2 hours. Upstream distance 4 kilometer, time 2 hours. Upstream distance is equal to 4 kilometer, time taken is equal to 2 hours. We know that distance is equal to speed into time. Put the values, that is 4 is equal to speed x minus y and time is 2 hours. Again 2 and 4 got cancelled. X minus y is equal to 2, equation number 2. We have equation number 1 below. X plus y is equal to 10 is equation number 1. Now we can solve it further by adding or subtracting. On adding, y and y will get cancelled. So let us add equation 2 plus equation 1 gives x plus x, 2x minus y plus y got cancelled, 10 plus 2, 12, x is equal to 12 upon 2 equal to 6. That is speed of rowing in still water is equal to 6. Now putting the value of x in equation number 1. X plus y is equal to 10. That is 6 plus y is equal to 10. Y is equal to 10 minus 6, or y is equal to 4. Now, after each word problem, you have to write the final answer in statement with the required unit. So what is x? Speed in still water. Therefore, speed of rowing in still water is equal to 6 kilometer per hour. This is the first answer. Speed of stream, or y means speed of stream. Answer is 4. So put the unit 4 kilometer per hour. So we got the answers 6 and 4. I hope all of you understood. Please remember that one point. If the speed in still water is x and the speed of stream is y, speed downstream will be x plus y and speed upstream will be x minus y. Now see the second question. 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by one woman alone to finish the work and also that taken by one man alone. Once again, class 8 unitary method. This question or this type of questions are called unitary method questions. Find the time taken by one woman alone to finish the work and also find the time taken by one man alone to finish the work. So, we know that in linear equation type questions, you can see finally you will be asked to find two things. These two things are taken as x and y. So, here also let the time taken by one woman to finish the work is equal to x days, because here the time is given in days, so x days. So let the time taken by one man alone is equal to y days. Now the next point is very important. If the time taken by one woman alone is x days, what is the work done by one woman in one day? One woman takes x days to finish the work. To finish the work means 1. So if the work is finished in x days, what is the part of work done in one day? 1 upon x. So 1 day's work of a woman is equal to 1 upon x. Similarly, what is 1 day's work of a man? 1 upon y. This is the most important part of this question. 1 day's work of a woman is equal to 1 upon x and 1 day's work of a man is equal to 1 upon y. Now come to the first condition. According to first condition, you are given 2 women and 5 men can finish the work in 4 days. So what is the work done of 2 women in a day? 1 woman in a day is 1 upon x. So 2 women in a day is 2 upon x. So 2 upon x plus, now 5 men are also working together. So what is 1 day's work of 1 man? 1 upon y. So what is 1 day's work of 5 men? 5 upon y is equal to, how many days are taken by them to complete? They can finish the work in 4 days. If the work is finished in 4 days, what is 1 day's work? 1 upon 4. So this question is entirely different than the previous questions. This is called unitary method type question. If 1 day's work is 1 upon x by 1 woman, 2 women's 1 day's work is 2 upon x. 1 day's work of a man is 1 upon y, so 5 men is 5 upon y. When they are working together, they can finish the work in 4 days, so 1 day's total work is 1 upon 4. This is equation number 1. Now see the second condition. Now according to second condition. Now see the second condition. 3 women and 6 men can finish it in 3 days. 3 women. So 3 upon x plus 6 men. 6 upon y. Then the work can be finished in 3 days. So what is 1 day's work? 1 upon 3. This is equation number 2. So the most important part of this question is making these two equations. 3 women plus 6 men takes 3 days. So second equation, 3 upon x plus 6 upon y equal to 1 upon 3. Now you know that these two equations are of the previous type. Let 1 upon x is equal to u, 1 upon y is equal to v. These two equations will be converted in terms of u and v. It will become 2u plus 5v equal to 1 upon 4. Remember, no change in RHS. U and V will come only in the LHS. So equation 2 will become 3u plus 6v equal to 1 upon 3. I hope all of you know the method of further solution of this equation. The important part of this question was how to make the two equations. So this is a totally different question. Please take care of it and solve it further. Now the last question, that is question number 3. And question number 3 is, Ruhi travels 300 kilometers to her home, partly by train and partly by bus. Means out of this total distance of 300 kilometers, she is traveling some distance, some kilometer by train and the remaining by bus. She takes 4 hours if she travels 60 kilometers by train and the remaining by bus. If 60 kilometers by train, what is the remaining distance? 300 minus 60 equal to 240 kilometers. Then the total time taken is 4 hours. If she travels 100 kilometers by train and the remaining by bus, remaining means 200 kilometers by bus, she takes 10 minutes longer. That means 4 hours plus 10 minutes. Find the speed of the train and the bus separately. So as usual, at the end of the question, you are asked two things. So that is our x and y. Let the speed of the train is equal to x kilometer per hour. Let the speed of the bus is equal to y kilometer per hour. According to first condition, what is the distance traveled by train? 60 kilometer. So what will be the distance traveled by bus? 300 minus 60 equal to 240 kilometer. So if the distance traveled by train is 60 kilometer and speed is x kilometer per hour, what is the time taken by train? So I will explain. Time taken by train. Time taken by the train is equal to, we know that time is equal to distance upon speed. Distance is 60, speed is x, so 60 upon x hours. So what is the time taken by the bus? 240 upon y hours. Now what is given? The total time taken is 4 hours. Therefore, time taken by train, that is 60 upon x plus 240 upon y is equal to 4. This is equation number 1. Now according to second condition, it is given if she travels 100 kilometers by train and the remaining by bus, she takes 10 minutes more. So what is distance traveled by train? 100 kilometers. Therefore time taken by train, time taken by the train is equal to 100 upon x. 100 upon x hours. So what is the time taken by the bus? If 100 is traveled by train, what is the remaining distance? 200. So 200 upon y hours. Then it is given she takes 10 minutes more. Therefore, total time taken 100 upon x plus 200 upon y is equal to 10 minutes longer than 4 hours. So 4 plus 10 minutes. This is in hours, this is in minute. So this is also to be converted into hours. That is 4 plus 10 upon 6. Now this is to be simplified. So equation number 2 is not ready now. Equation 2 will be that is 100 upon x plus 200 upon y is equal to 4 plus 10 upon 60. 0, 0 got cancelled. 4 into 6. 24 plus 1. 25 upon 6. This is equation number 2. Once again, there is upon x and upon y in equation 1 and equation 2. So what is the method of further solving these two equations? Let 1 upon x is equal to u, 1 upon y is equal to v. So equation 1 becomes 60u plus 240v is equal to 4. Equation number 3. Equation 2 becomes 100u plus 200v equal to 25 upon 6. Equation number 4. Now solve 3 and 4 by elimination method. You will get the values of u and v. Then come back and putting, you will get the values of x and y. Anyway, these three word problems are very important because one of these three have been asked in the board exam several times. So please practice all these three questions, three word problems. Question number 2 and 3 are not completely solved by me. Equations are made. You know the method to further solve it. So that is the end of chapter 1. Pair of linear equations in two variables. I hope you understood the entire chapter. I will come with the summary of this chapter and some extra questions in my next video. So please practice all the exercises of NCERT book and ask your doubts in the comment box. Till then, thank you for watching my video. Take care. Have a nice day.